All right, we're going to go over our units 7 and 8 notes. Not going to go over a ton of things, but there is a lot of material here that you need to look through. So we're just going to look at what all these units cover, which will be a huge portion of the statistics test. Um, I I know that at least one of the free responses will come from this unit, but probably more. So let's take a look. With confidence intervals, that's when we are estimating a parameter, estimating the true proportion, estimating the true mean, or estimating whatever. So estimating an amount, and we do panic for that. When you do your conditions, your random, independent, your large enough, remember the proportions condition is at least 10 successes and at least 10 failures, but for means, you have at least 30, or the problem was stated to be approximately normal. So if your sample size is not large enough, go see. Did they tell you the problem was approximately normal? Or if they give you individual pieces of data and it's small, then you could do a dot plot and then check for sun, that's somewhat symmetric, unimodal, and no outliers. And then conclude, don't forget to conclude with the approximately normal model applies. When you name the interval, that's going to be your 1 proportion z interval, your 2 proportion z interval, your 1 sample t interval for means, your 2 sample t interval for means, those things there. All right, and then your conclusion, I am 95% confident that the true blah, blah, blah. Okay, now taking a look again, just reviewing the components of an interval. Here is the actual formula that is on the formula chart. That's how it looks. So see, this statistic can be many things. It can be your p hat, if a proportion problem. It can be your x bar. It could be p hat 1 minus p hat 2. It could be the difference of proportions. It could be the difference of 2x bars, plus or minus that critical value, which is a z star or a t star, inverse norm of one tail, and then your standard error. This is that standard deviation that comes from the formula chart. Remember that this part past the plus and minus is the margin of error, because you have your statistic, which is right there in the middle of an interval here. Then you have your margin of error up to the upper bound and your margin of error down to the lower bound. If you are given an interval, then of course you know that that statistic is right in the middle of that interval. Computing that critical value, whether it's a z star for proportions or a t star for means, if they ask you to be a certain confidence level is what's in the middle. You're going to inverse norm one tail or inverse t one tail. Now keep in mind, when you inverse t one tail, you do inverse t of one tail, comma, degrees of freedom. You have to include those degrees of freedom. All right, and then here just is how to put this in your calculator, and then you can read this interpretation. So the interval interprets, so when you finish a panic, you're saying, I am 95% confident that the true proportion of whatever is between this number and this number. So your interval interprets those numerical values that estimate that parameter. But confidence level, that's talking about this 90% thing. That is not talking about these numbers, 0.16 to 0.26 or whatever. You are talking about if you had many, many proportions and you made a ton of intervals, if you had many samples, I'm 90% confident that about 90% of all of the 90% confidence intervals we could make will contain the true parameter, the true proportion, the true average, the true difference. Remember, they want to stick in there, and a good way to take out an answer choice is they'll say will contain the sample proportion or a sample result, or they'll even say contains these numbers here. No. All right, so those are your watch out fors on the interpretation of a confidence level. Now, again, with two proportions, see, you're just estimating that difference in the proportions. This formula here is on the formula chart. And then you can do a 2 proportion z interval in your calculator. Make sure when you put these numbers in, they are whole numbers. The X is a number of items. Do not put like 0.32 for 32%. And if you put 0.32 times 96 or something to get the number, if it is not a whole number, then you need to round it to a whole number amount. All right, and then here are some examples of the conclusions for the differences. I have an example of a difference that includes 0. That's this conclusion example number 2. See, it goes from a negative to the positive. So remember, we write which way we are subtracting for our difference. So I'm 90% confident that the true difference between this is between, I always do it in terms of the first one. This percent lower for the first up to this percent higher for the first. Okay, so I always do it in terms of the first. This percent lower for the first to this percent higher for the first. And since 0 is in there, there could be no difference. Up here, the difference here, the proportion of Alito students who own an iPhone X is less than this much less to this much less. So the entire interval is, but since the entire interval is contained below 0, there is evidence that the proportion of Alito High School students that own an iPhone X is less than that of the watch. Okay. Now I think this is the same thing. Oh, changing the size of the interval. Things that change the size of the interval. Okay. So the things that are going to change the size of the interval, obviously, are these things that are the margin of error. So, this, where that sample is located, of course, that's just kind of shifting it up and down the number line. But these components will change the margin of error. So let's talk about that. The critical value. How will that affect the spread of the interval? Well, of course, the more confident, the more area in the middle. So the wider the interval, the bigger the critical value. More confidence, bigger, wider interval. And then, of course, your standard deviation. Of course, this standard deviation. And what comes into play when affecting a standard deviation? Your sample size, of course. So as we know as n goes up, as the sample size gets bigger, your standard deviation is getting smaller because you're dividing by a bigger number. Now, you do need to be aware of the numerical component that affects the size of the margin of error and sample size. And so that's, again, we've seen this before, but remember that if I say, hey, let's make this sample size 4 times as big. So if I put a 4 here with the n to make the sample size 4 times bigger, in order to balance this equation, what I actually put in here was the square root of 4 as a fraction. I did 1 over 4 square root. So that comes out to balance this equation and make the left side equal to the right side. That's 1/2 on the margin of error side. Over here, if you did 9 here, then of course that would be 1/3 the margin of error, and so on. And then of course with our 16, if we put our 16 here, then that's going to be your 1/4. All right, now if you are solving for sample size, then you are setting, they'll say, hey, we want you to have this size margin of error. So that's the margin of error equals, and then you fill in this information. 94% confident. So then that would be whatever that critical value is for that. You're going to do the inverse norm of 1 tail. Let's see, 94%. In the middle puts 3% on the edge, so 0.03. And then, now let's talk standard deviation. You do not know the true parameter. You do not even know p hat. They didn't tell you that. So if the best it can be is if you use true p, but if you don't have that, you can just use p hat. The worst case scenario is you don't have that, so you got to use your 0.5. And then you put it over n, and now algebraically solve for n. All right, so that was all the proportions. We did those in Unit 7. Now Unit 8 is all of the means, but the ideas are the same, remember, with the exception of the fact that we are dealing with t distributions instead of the normal model. T distributions, why t distributions? You have to know. We do not have the standard deviation of the population. Okay, you're taking the average shoe size of all Aledo High School students. Well, we don't have that true standard deviation for that. So the best it can be is if we use the sample standard deviation. Therefore, there's more variability happening. Therefore, we have these wider, more varied curves. And those are the T curves. And remember that Gossett computed those for us, and so we have a ton of different ones for each different sample size. So therefore, our degrees of freedom are going to be based off that sample size, n minus 1. Now for the lines that we just did in Unit 10, because this was two-dimensional, it was n minus 2. Okay, but for the regular ones, it's just n minus 1. Same thing here for the t intervals. Notice it's the t star instead of z star. Notice this is the standard deviation for sample mean. And this is on your formula chart. So don't go be a superhero and try to memorize these. They're sitting there, right there on your formula chart. All of this is the same as the proportion ideas. All of this is the same as the proportion ideas. Oh, looky here though. Inverse t of one tail, comma, degrees of freedom. I should put that in there. Okay. And then you can do the t interval in your calculator. Here is the interpretations about the true average amount. Okay, and then here is about the difference between two means. So here we have this difference between two means. And again, this formula is on the formula chart for that standard deviation of the two means. All right, and then two sample t interval there. Then we're going to run into these interpretations. So remember that with the conclusions, again, it's a matter of first, make sure you are stating which way you are subtracting, and then it's a matter of if you have 0 in the interval or not. So in this case, the average number of hours a week Aledo High School students, AP students spend on homework is between 1.1 and 0.25 whatever units less than the Southlake students. Okay? Maybe because we're smarter. I don't know. We need to fix that right there. And look, DF must include the DF. T, not Z. Must include the DF when you are writing up a phantoms or a panic. Here is again the conclusion. This one went between for the something they're waiting on the way to work or whatever is between this much lower and this much higher than the other one. Okay, and then of course your hypothesis test. All the same for your hypothesis test conditions. You're stating that I think we've done these so many times, so we're just going to skip on through that. And I've taught you always to do these one proportion Z tests by hand, but guess what? Technically, when it comes right down to it, doesn't matter. Okay, if you were doing a free response, really, you can just write the fill. You do need to fill this in here because you need to make sure all of those values are clear what they are. You have to always make sure you are stating what the values are. And then here with the two proportion ones, we went and did our in the calculator. And let's talk about this real quick, this interval and this test connection. So if you reject the null, then that null hypothesis would not have been in your interval. Or the flip side to that, if you made an interval and it does not contain HO, then upon running a test, you would expect to reject that null. Really important that you catch that relationship there. Now, if you make an interval and the interval does include the null hypothesis or the value you are investigating, if it includes it, then you probably would fail to reject it upon running a test because you're saying you're 90% confident that it could be that. All right. And then for the two proportions, remember we're interested in, does our interval contain 0 or not? If 0 is not in the interval, then I have evidence of a difference. So if I go run a test, I probably would have rejected the null hypothesis. And finally, if 0 is in there, then I do not have evidence of a significant difference. So if upon running a test, would fail to reject. All right, so here is a summary of all of the conditions. I remember that on the two proportion ones, we need to make sure we are saying that we're doing it for both populations, and that we are saying that those samples are independent of each other. So the subjects in one sample are not in the other. Keeping that in mind. And then here's all the same exact stuff, but for means. Going to scoot through all of that. And again, if you have to, you may have to do sun if they give you the individual pieces of data where you make a dot plot and everything. This is a lot of information. So I think I'm going to split this to, I'll go ahead and just do this one last concept and then I'll do the error component in a separate video. So here is the page to discuss if you were confused on what you do if it's a one mean versus or matched pairs versus two independent means. Here we go. What makes the data matched or paired instead of two independent means? All right. So I want you, peruse this and you can see what makes it one versus where they are matched. And then you can see, remember that what you do calculator wise is you're putting your information into L1 and L2, and then you're going to do the subtraction. Pay attention to which way you subtracted. We typically do after minus before, L2 minus L1, and that goes right here. And so then you're going to be really just running a test on this difference, and we're interested in the average of these differences only. I don't care where they started or finished. I'm only interested in where those differences are. All right, so you can read through that. You can also read through these conclusions and how to do, see the assumptions are for one set of data. That one set of data, which is those differences in list 3. All right. Each pair does need to be independent of the other pairs. So that's where that independent component comes in. And so there we go. Here is, I would study this. This is a good descriptor of how it looks with a side-by-side two means t-test, two independent means versus matched pairs t-test. So if I was going to read through any of these problems to get the gist, this would be the set to do. Also shows the different ways to do the computer or the calculator and doing the interval. So that's just hugely important problem. That is definitely something, what is that, pages 38, 39, and 40, that I would peg as something I need to sit and go through myself and read through that. Okay, so that takes us to the errors, which I'll do in a separate video, but as just a quick little review. But you have that here, and so we'll stop there for now and continue with the errors and the mechanisms that can change the probability of those errors in the next video.